To good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to this learning experience brought to you by Mogenius. My name is Cody, and welcome back to Techstrong Learning. We've got an exciting panel ahead, but first, I have just a couple of housekeeping notes I'd like to review with you. First of all, we are recording today's session. So if you happen to miss any of our discussion, if you'd like to watch at a later time, or if you'd like to share with your team, you will be receiving an email with a link to access that recording on demand, and you'll get that shortly after we conclude this live session today. Now, if you'd like to interact with us, there are a couple of ways to do so. The first and the easiest option is that chat tab. You'll find the chat tab on the right side of your screen, and when you do find it, I want you to let us know from where in the world you're joining us. If you have any specific questions for our speakers today, we do want you to send those to the Q&A tab, as that just helps us keep organized, and we'll be taking breaks periodically throughout our session today to be looking at these questions. So send them in when you got them, and we'll do our best to answer them all. Additionally, before we close things out today, we are giving away two $25 Amazon gift cards. And last but not least, if you jump over to that handout section, you will find that there's one resource there for you that might be a lot of help. So feel free to grab that at your own leisure. So our conversation today is on how platform engineering minimizes cloud-native complexity. And I'm joined by Garrett Schumann, co-founder and CEO at Mogenius. And we're also joined by Jan Lepsky, co-founder and chief product officer at Mogenius. So Garrett and Jan, thank you so much for joining us today on Techstrong Learning. Garrett, do you want to take us into our conversation?
Yeah, thanks, Cody, for the introduction, and thanks everyone for joining. I'm excited to be here today and talk about platform engineering. First off, you already introduced us. Jan and I are co-founders of Mogenius. We started the company 3 years ago. We're a group of cloud native enthusiasts and Kubernetes experts. And our goal is to support platform engineering teams in the platform engineering initiative with an internal developer platform that streamlines software delivery and operations in cloud native setups, especially in Kubernetes environments. And that helps you to define reusable standards and provide developer self-service from end to end. And with that, you can achieve higher development output and reduce your time managing cloud-native complexity. As Cody pointed out, there's a handout that you can download. It's our guide. It's called the Hitchhiker's Guide to the Platform Engineering Galaxy. Gives you a good overview of platform engineering and internal developer platforms as well. So why are we talking about platform engineering today? Gartner just recently, just a few days ago, published an article with the top 10 strategic technology trends for 2024 and listed platform engineering as one of them. We've seen the rise of cloud native, starting from cloud computing, and platform engineering is the next evolution in DevOps practices to manage the cloud native complexity. So it is for any software business and super important trend. And we'd like to talk about a couple of topics here today. One is how cloud native actually has an impact on developer experience and what we call cognitive load. Secondly, we want to understand better what is developer experience, why it is important and has an impact on developer productivity as well. And lastly, how do you get started with platform engineering? And should you build your own platform or buy an existing platform out of the box? And after my theoretical part, Jan will take you through a live demo, a real life example of an internal developer platform, the Mogenius platform. So what is the current cloud native reality? And we call it the good, the bad, and the ugly because it has all these sides to it. Let's start with the good. When done right, a good cloud native adoption simply increases your developer velocity. And it helps companies to simply grow faster and reduce their time to market. It ensures scalability, and with Kubernetes as a cloud orchestration tool, you have demand-based resource management that can be very cost efficient. And in the end, it also increases your resilience, your fault tolerance. It reduces your number of single points of failure through distributed systems and a microservice architecture. So these are all great things. But there's also the bad side. It comes at a price, and the price is complexity. Cloud native brings simply new challenges by managing distributed systems for debugging, tracing, monitoring. It's a more complex configuration management for operations and developers, and that requires a new set of skills, either that you have on board or that you bring on board, or you train existing skills, but it can be a scarce resource to manage this new reality of complexity. And also this big jump in complexity just is an explosion for the cognitive load for developers. There's so much more going on and so many more tools and workflow varieties that are going on that can lead to a deteriorating developer experience. And that again leads to a decreased developer productivity. And in the end, I mean, it's a relatively young engineering practice, coming from, or that's come up in the last 10 years, but, there's still not that one standard set of best practices. And those are just simply bottlenecks to achieve those benefits. And it's interesting to look at how companies have adopted cloud native. McKinsey came out with an article, I'm happy to share the link later as well, on developer velocity and how it varies across industries. And they looked at a couple of dimensions to assess, the adoption and maturity rate. And one is technology, so architecture, infrastructure, testing, and tools. And you can see the darker the tile, the higher the developer velocity. And you see that native software companies are pretty good at delivering a high developer velocity. And as you move to retail, health, to media and communications, adoption is not as high, and developer velocity is much lower. And that goes through the other dimension as well, working practices, agile processes, security and compliance, as well as organization and culture and talent management as well. So there's a lot of potential here in most of the industries they looked at. But what in the end is developer experience? If the assumption is that cloud native can have a negative impact on developer experience, how to define it? And actually, it's pretty simple. It refers to how easy or difficult it is for a developer to perform essential tasks needed to implement a change. And when you increase the complexity, then even simple tasks or tasks that were simple before can become more complicated and difficult to manage. And a positive developer experience would mean that these tasks are relatively easy to manage for the team. And we measure that developer experience basically in three categories. First one is feedback loops. So reducing delays in software delivery, enabling rapid feedback, making sure that you course correct when needed very quickly. Second is cognitive load. We already mentioned that. There's just a mental processing bandwidth you need to perform tasks. And again, that's influenced by the complexity and also the organization of workflows and information. And lastly, the flow state. So how immersive of a state are your developers or the development team, and how can you achieve that to create energized focus enhance productivity and job satisfaction. So we call, when they're in a tunnel, so they can really focus on coding without many distractions. And those three dimensions define a good developer experience, or the lack thereof, a bad developer experience. If you drill down a little bit more on some of these characteristics, so feedback loops, cognitive load, and flow state, and look at the metrics, these are some questions you can ask and look at in the organization to determine that has it already happened. I mean, how good is the developer experience in my team? So a big part of that is perceptions, obviously based on reality, but also how does your team or how do the developers perceive these feedback loops? So how satisfied with test speed and how long it takes to validate a local change, or how long does it take to deploy from local to production? So the perception has a big impact on the satisfaction of the team. Cognitive load, how is the perception of the complexity of the software project, and how easy is it to debug and find errors as well. Same thing with documentation, how easy is it to access and to understand. Same goes for flow state. What's my ability to really focus without interruptions? How clear are my goals and the projects I'm working on? And do I feel like I'm constantly being on call and disrupted by other tasks? Second part is, besides the perceptions or workflows, so your system and process behaviors. So the time it takes to build a package for delivery, a software package for delivery, your turnaround time for code reviews, your deployment lead time, so the time it takes from code to production. On a cognitive load side, how fast do I get my questions answered to get to the next step, and how many manual steps does it actually take to deploy a change? How often is documentation updated, so I don't have to actually ask that question? And then the flow state, how easy it is for me to reach that tunnel. So how long and how frequent are the blocks of uninterrupted times when I don't have meetings or interruptions, or I have unplanned tasks or requests, or there are incidents that require my attention as well. And lastly, if you want to look at some KPIs, I mean, your North Star metrics, look at the overall perceived ease of delivering software, your engagement or satisfaction in the team, and the perceived productivity. And so this bad side obviously has an ugly side to it, an ugly consequence, which is you have a deteriorating developer experience that comes from the complexity, working in an unoptimized cloud native context. And there's some drivers that cause this, and we've already covered some of this or touched on this. One is the increased cognitive load. There's only so much you can process mentally, and if it's too much, if there's an overload, you stop being productive, and you actually in your core task. The configuration overhead is just too many buttons to press. Inconsistent environments between development, testing, and production again causes not a smooth process, a streamlined process, but you have to start from the beginning. Service dependencies. The larger your microservice catalog grows, the more complex that is to manage. Monitoring, debugging, in the cloud native context, require a more sophisticated knowledge of tools and configurations as well. These are challenges. To comply for compliance and security, to make sure that you meet the standards. Again, that's also complex and can have a negative impact on the developer experience. Operational silos between operations teams, development teams, security teams, that can lead to friction and over-the-fence operations. So writing tickets, I need a new environment. I need resource provisioned, something that maybe used to do yourself, or handle end to end. And if it's in an operational silo, you write a ticket and you throw it over the fence, you wait for an answer, and that again has a negative impact on your feedback loop and the whole deployment process. Latent issues, so something that only comes to light when you actually release it into a cloud environment that behaves differently from your local environment, and just a sheer number of tools and configurations can be overwhelming. There's too much choice out there. And in the end, you can say, so what? Why is that important? Developers should simply code and get the problems fixed, but it has a real impact on your business output as well. It has an impact on developer productivity, which leads to reduced productivity in your company, longer time to market, slower growth, increased costs, and lead to lower quality products. Innovation cycles get longer. It can deter top talent from joining your organization or even leaving your organization, up to customer satisfaction. Has an impact on your operational resilience, the time it takes to fix a bug or a failure in the configuration. It also has compliance risks and security risks, and you build up a lot of technical debt over time. And you can see this, this is again part of the McKinsey study on developer velocity. If you have a high adoption rate or a high developer velocity, it leads to faster revenue growth. If you look at the left side, which is the low developer velocity companies, and their revenue growth over a span of 5 years, compared to the right side, it's a factor 4 by 5. And if you drill down to the individual industries, I mean, software again, pretty mature in terms of adoption and optimizing the developer velocity. But if you move to automotive manufacturing, it's even by a factor 10. Compared the companies with a low developer velocity compared to the ones that have the best developer velocity. So it really has a true impact on your business, and that's why it's super important for engineering teams to focus on this as well. To stay with the movie analogy, what's the answer to the cloud native complexity? And that is platform engineering, or it's a part of the answer to that. So that's the beauty of it. But there's also a sleeping beast in platform engineering as well. We'll get to that in a second. So what is platform engineering in a nutshell? It's a practice to design and deliver tools and workflows to enable end-to-end self-service for developers in the entire development process. And the main focus is to reduce cognitive load, because that creates focus and that creates better quality and productivity. What are the goals of platform engineering? One thing is, if you want to introduce platform engineering, one of the core elements is reducing complexity, and it starts with infrastructure complexity. You want to hide the intricacies of the underlying infrastructure and orchestration, so the developers can focus on coding and not the operational side of it. Second goal is standardization and consistency. You want to establish a consistent development, deployment, and operational process across the entire organization. So independent on what team and project it is, you want to have consistency and standardize and have reusable configurations. Enhance your developer experience, streamline development workflows, and just simply reduce friction and accelerate your cycles. Automate repetitive and routine tasks and free up DevOps teams for more strategic high-value work, which creates operational efficiency, but also cost efficiency with smart and optimized resource utilization, and efficient scaling. And when it comes to security and compliance, you want to be able to enforce it, and you want to be able to automate and adhere to organizational and regulatory standards without high overhead. And this is also a core element, implement comprehensive monitoring and logging. So you gain insights into failure points and simply improve your system reliability and the performance. As a big part of platform engineering is the creation of an internal developer platform. So what role does that play in platform engineering? In the end, the internal developer platform is a layer between your existing tool chain and resources and the stakeholders within the engineering organization, primarily developers, but it can also be your FinOps team or your security team, DevOps team. And they each access the internal developer platform with their abstracted view of the underlying infrastructure and resources. Sorry, skipping back. So what's the purpose of the internal developer platform? So one is to enable developers to independently manage applications from development to production, which creates just more agility and reduces operational bottlenecks. So autonomous app lifecycle management. Simplified cloud native. Abstract the complexities of cloud native so that developers or a development team can actually leverage it without needing that deep expertise that is typically required to understand the tools and the complexities that are underneath. Standardization, we already covered this. So yeah, uniformity in development and operational processes, ensure consistent quality across teams and projects, and compliance enforcement. So these are all part of the reason why you want to have an internal developer platform. This is a typical setup of an internal developer platform. So you start with a developer portal, which enables self-service for developers. It's based on infrastructure as code. A core element is typically Kubernetes operator, which connects Kubernetes clusters with the developer platform, helps orchestrate workloads and resources in the cluster, provides insights into metrics and traffic. You have aggregated monitoring and logging for observability. You connect to your repositories for version control and for Git workflows. And another important element are service catalogs to have reusable templates and configurations that you can use for other projects, other environments, and simply clone them and still make sure that the right version is used, that the right environment variables are used. It unifies governance, so you can abstract away from the governance to the individual cloud providers, for instance, or tools that you use for your workflows, and have an abstracted access, which simplifies your visibility on who's actually working on which project, which resources are they using, and what access and rights they have, and which roles they have, and without having to give them direct access to infrastructure and the tools. A big part is that internal developed platforms provide environments. These environments are highly automated and are part of the self-service portal. So you can spin up a ephemeral environment, a production environment that meet your standards, that work with your tools, streamline the process, and are also safe and secure to use for your developers. CI/CD are an important part, so you don't want to throw out what you've built already on your tool chain, your automation. You integrate with the processes, but you make it more visible. You make it visible to everybody in the process. And again, you can automate the delivery then as well. And you connect to existing resources, whether that is any public cloud, private cloud, on-prem databases, and Kubernetes does play a big part in the cloud native adoption as well, and is a great tool, but also creates complexity that you abstract away with the internal development platform that way. So what do we achieve with an internal development platform? Self-service capabilities for resource provisioning that provides more autonomy, automated workflows through automation that reduces simply manual intervention, security and compliance automation, security checks, container vulnerability checks, compliance validations that you set standards, policies that you define once, and they're automatically applied to new environments and projects. And it's a smart way to integrate your existing tools and systems for a seamless development experience. And that's the beauty part again. With that as a result, you'll have reduced cognitive load across the development team. You have consistent environments, fewer feedback loops. There's more autonomy, more ownership throughout the entire application lifecycle. It lessens the burden on DevOps or SREs to provide that support. So you're not a Kubernetes support desk anymore. You can actually focus on strategic tasks. You have a lot more transparency across all stakeholders and teams within the organization, and better governance that is on a level for across all projects is easier to manage and also more secure. In the end, that makes it a better developer experience. But so that was the beauty. So where's the beast? How do we actually approach platform engineering? How do you get started and how do you implement it? First, let's look at signs why or if you should approach platform engineering. Again, it's one answer, it's one practice. There's typically never a 100% right answer, but it can be a pretty good answer to your cloud native challenges. So you look at signals, so your service interruptions or outages, deployment failures, rollback rates, number of incidents or incident tickets, support requests, rising costs with your infrastructure, or simply feedback from your developers that have an issue with the operations. Look at patterns. Do you have recurring bottlenecks in resource provisioning, for instance? Sorry about that. Skip forward. Do you have silent operations that lead to communication collaboration barriers? Do you have a lot of manual interventions for deployments and operational tasks? And then you can look at your organizational pain points, frustrations in your developer team, difficulty maintaining security and compliance standards, challenges when you debug or troubleshoot. Do you spend a lot of time setting up environments and configurations, or do you fail to meet your scalability demands? And then there's some quantitative criteria, which I recommend to look at the DevOps productivity metrics, lead time for changes, so from code to production, how is your deployment frequency, what's your failure rate when you deploy a change, how long does it take to recover from a failure, on average, efficiency metrics in terms of costs, transactional costs, and also, how many percentage of your processes are actually automated versus manual. And then simply ask a few questions around those, because in the end, platform engineering and the establishment of platform teams is a project again. It's a software project. And typically what we've seen from the many projects, cloud transformation projects or cloud migration projects, you typically choose a technology very, very fast. In this case, it's Kubernetes, and wow, yeah, cool. It's an orchestration tool. It's powerful. It's by Google. Now it's open source. Now let's go for it. And then you look at the landscape of tools, and there's hundreds of tools available for every use case and need in the team. And then you actually start building and connecting and configuring, and you all of a sudden start you're putting together an IKEA shelf, and you're frustrated and start drinking. So that's, in the end, you put a software project on top of an organization that builds software projects. So how do you decide when to build your own platform and when to look for an out-of-the-box internal platform or solution for platform engineering? First criteria is the level of customization that you need. Is it required to be unique to your organizational needs, or do you have single workflows and processes that need to be customized based on an existing out-of-the-box solution? Do you have the expertise in-house, or can you get the expertise in-house? Otherwise, look at the vendor expertise that's already there. The financial commitment is the budget available to build, so the capital expenditure, but also the operational expenditure, the resources for development of internal platforms, versus a vendor licensing and subscription fee. Time to market. Is it a long-term strategic project that you want to commit the time to, or a solution? So of course, also willingness to adapt. It's a different process, building versus selecting a vendor. In both cases, you have continuous nurturing necessary in the long term. So build your own platform. If you're a large scale tech organization with very unique needs and you have the in-house experts and it's a strategic initiative where you have a long-term vision for. If you're a smaller tech team, less than 500, let's say, you want to get started fast. You don't want to have the hassle of maintaining and developing the platform. The focus is not so much on customization, and you simply don't have the in-house resources. Then it's better to buy and partner with an existing vendor. So a couple of questions to assess your deciding on whether you should make or buy. In terms of timing, is it core of your business model? Do you have the necessary skills? Can you fill the gaps in your skill sets? Do you have the budget? Do you want to have an implementation project or and maintenance in your team? And it's a question also, can you do it profitably? So is your organization large enough to justify a platform team and platform operations? In the end, how complex is your infrastructure as well? So with that, I would like to first, before we hand over to the demo, I'll have a look at the questions. I'm going to go for the first question. Wonder if platform engineering is mainly effective only for Kubernetes environments or adoption? We want to get there, but not yet. We mainly use Azure App Service functions with Terraform as our IAC tool. Can platform engineering still help? Absolutely. I think Kubernetes is often the reason why you absolutely need platform engineering. That doesn't mean that without Kubernetes you don't have a need or a reason to adopt it. I think the practices and what you want to achieve, the self-service, automation, makes sense even without Kubernetes. But Kubernetes simply requires a lot of times, just because of the complexity and also the pitfalls and the rabbit holes you have with Kubernetes, that you need it. Second question, what strategies does platform engineering employ to mitigate the risk of vendor lock-in and maintain flexibility in a multi-cloud environment? Very good question. I think that's an important point. You should always look at when one end, it helps you decrease vendor lock-in because you abstract a lot of the proprietary technologies away, and you focus more on scripting, infrastructure as code, configurations that are agnostic to individual proprietaries. You can work with Terraform providers, for instance, and a good internal developer platform engineering practice should focus on that as well, and that especially in multi-cloud environments, where take, for instance, the Kubernetes agnostic work.
Well, I think we lost Garrett here,
so tremendous. And
Garrett, you were lost for a couple of seconds.
I was lost for a couple of seconds.
Maybe you would like to repeat the answer on the last question, and then we can keep going.
Okay. So that question I will hand over to Jan. Perfect question for you, Jan, and a segue to your demo. Thanks, everyone.
Right. So last question is, since each application can be different, built-in deployment requirements are different, if there's any guidance on how we can create self-service pipelines. So that's an interesting challenge because as we see it, self-service requires some level of generic definitions that you would need to set before handing it out to your team. So in order to offer self-service, you need to think through the pipeline. You need to define the steps. You need to define the types of pipelines that you want to offer. What we usually see is that pipelines are something that are for the broader developer audience set up by operations to some degree. So, or at least created by a couple of senior people on the team that hand this out to the wider audience in the development teams. So this is something that is usually centralized, where you think through the steps, also requirements in terms of security checks, vulnerability scans, things that from a DevOps perspective, you definitely want to see taking place in your pipeline. So this is something that you do not offer in a self-service manner to 100%, at least not let the teams build their pipelines from scratch in each way. A good way maybe to offer some flexibility in the pipelines is, for example, GitHub Actions and offering templates for actions that every team can use in their repositories with certain configurations, so that you at least offer a set of pipelines that are predefined, and then it's up to the teams to configure them in their own way. So we made great experiences with GitHub Actions as a tool for individual pipelines, but that you can standardize and template at the same time. I hope that answers the question. So that being said, let's look at how you could tackle an IDP with Mogenius. We'd like to walk you through a little workflow by onboarding a team to a Kubernetes cluster. So the platform we're talking about, the Mogenius platform, is centered around Kubernetes, as this is the most common platform that we see in any cloud native environment. So we are right now talking about a setup where you have a DevOps team that is running the infrastructure, and then you have a couple of development teams around that that want to deploy on the clusters and manage the applications in a self-service way. So we're going to jump right into that. I'm now starting with a Kubernetes cluster. So the challenge that we have is we have a GKE cluster here on my Google Cloud account. It's pretty much a blank cluster, and we want to offer that to the team. We want to hand over the infrastructure and allow them to do their work on the cluster and start going hopefully fast. So to begin, we're going to connect with the cluster. And I'm going to do that on the terminal here. And then we'll use the tool K9S to see what's going on the cluster and to monitor our setup with Mogeneous. So as you can see, that's just the default services from the Google Cloud here, from GKE solution. And next thing we're going to do is install Mogeneous on this cluster and connect the Mogeneous platform with this cluster. So I'm going to switch to the Mogeneous platform. I have an account already, and I have an organization. So we have a tenant system here where we can create multiple organizations. And this is our empty organization, which we want to fill with projects and then offer this to our team. So this is the developer portal that we're going to use. We have the option to manage clusters here, and you can see that we already have a couple of clusters. So there's another GKE cluster here, there's an UpCloud cluster, and we have a local cluster with Docker Desktop for testing. And now we want to onboard another cluster in our organization. So I'm going to add one here, type in the name of the cluster, and then we can search for the type of Kubernetes that we're running here. So the Mogeneous operator supports a wide range of Kubernetes clusters, basically any Kubernetes version that you see around currently, if it is a hyperscaler or on-prem or local clusters, mostly supported. So we're going to select Google Kubernetes Engine here, and then we can set up the installation. So the way this works is that Mogeneous has an operator that we're going to install on the cluster using Helm. Once the operator is installed, we can manage the cluster and deploy services through the internal developer platform from Mogeneous. Alongside with the operator, we can also deploy a couple of useful services like Certificate Manager. If we don't have one already, we can use a default backend. I'm skipping the metrics server because GKE brings one by default, and we can get an ingress controller. So goal is right now to have everything ready just by installing this Helm chart. So I'm copying the commands and then moving over to the terminal again, just pasting that here, and then we'll start with the installation. So we're going to see in a couple of seconds that the installation will start, and some pods will be created, which will be the operator and the accompanying services. So now it's starting. I'm going to zoom out a little bit to make this visible more easily. And there we go. So installation is starting. We can watch the progress also in the platform itself. We're going to see that it will be connected in a couple of seconds. So this will be the most important step. We're done here. We'll do one minor thing on the cluster itself because I know that we want to retrieve an IP address for our cluster, so the load balancer IP. Modify a couple of settings here where the default doesn't work for us. And that's it. And in a couple of seconds, this will refresh, and we'll get an IP address that we can connect with our domain. So we want to get a domain connected with our cluster, basically. Until this is ready, we're going to fill out some settings here. So let's move over to the settings to complete the setup. We can enter a region here to better monitor this in our cluster overview. So this cluster is based is living in Germany, in Frankfurt. Then we can already enter a domain. So I'm going to choose my own domain here. We're going to connect that in a second with the load balancer IP. And then we can connect a container registry. So Mogenius has a built-in CI/CD pipeline, and as you've seen, as part of a developer portal and as part of an IDP, it's useful to connect a CI/CD pipeline to allow full workflow automation. So there's two options for that. Mogenius has its own CI/CD pipeline, or you can plug in existing ones. And for the own pipeline, we're going to connect a Docker registry here. Going to grab a token real quick, and that's basically it. Now let's check on the IP. There it is. So I'm gonna copy that, and I want this in the description. It's more handy. And then we are almost done. So right now we need to just connect this. Oh, that's wrong. We just need to connect this domain. So I already have my DNS settings here. Gonna paste in the IP address. We need two records. So one for the subdomain itself, and then one for wildcard subdomains, so that we can that Mogenius can create multiple services under this under the subdomain. So yeah, this is it. This is all you need to do to connect the clusters. Now let's have a look what we can do with that. Once the cluster is connected, we'll get an overview of the resources here. We'll get an overview of the projects. So there's no projects on the cluster yet, but once the teams get to work, we can monitor that and see how many teams are consuming resources and what they're doing here. We also have the option to modify workloads. So as an admin, this is always useful, apart from the abstraction that the developer platform offers, to have direct access and to really see what's going on cluster level here. And without context switching, we can access any deployment, any pod on the cluster, edit YAMLs, and see what's going on the cluster itself. But we want to offer this now to our development teams. So let's create a project. This is the way how we onboard the development team to the Mogenius platform and to work on the Kubernetes cluster without actually working on Kubernetes. So we can create a project by selecting the cluster that we want. So giving that a name. Sorry. Then we can set some resource limits. So I want to assign a specific set of resources to the development team on the cluster. And now this is what the team will get. This is how the project looks like. They have a dashboard to monitor resource usage. They get a CI/CD pipeline overview. No activities yet, obviously, but we're going to change that in a couple of seconds. And then we can create environments. So by default, we have this production environment, and we can easily create multiple environments here. Let's say we want a dev environment as well. And what Mogenius is now doing in the background, you can see this in the logs here. The operator is taking care of everything on the cluster level that's required to create this environment. For example, namespace creation, secrets management, network policies. So this is how it works overall. You do something on the user interface or on the CLI or via API, and the operator will take care to manage that on the Kubernetes cluster. Now we are done with the environments. Now let's see how we can deploy services. There's a couple of options to do that. Currently, we can deploy repositories right from GitHub or GitLab, and this is using the internal CI/CD pipeline. We have a template library. So as we covered in the presentation, templates and the service catalog is a vital part of the internal developer platform, and Mogenius has one as well. We have the option to deploy container images. We can also use Docker Compose to deploy a full environment by just pasting in the Docker Compose file, and we can run cron jobs here and configure Kubernetes cron jobs. Now to see how this works, let's deploy a simple image at first. So we want to deploy an Nginx. Let's say we use that. I just use the Docker Hub reference here, but you can also paste in any other container registry link and this will work. We'll pass the container settings. We don't need that right now. We can set resource limits here for our service based on the project limits that we have overall. We could set some environment variables, but let's skip that as well for now and just enter the internal port. We want to expose our service and create it. And now you can see that the container is being deployed on the cluster. Logs are coming in one after each other, and the service is deployed. So we'll get the service logs here, and now the whole service is available through an external host name. And a certificate is being assigned automatically with Let's Encrypt. This is going to take a couple of seconds, so until then we'll see this warning. But in a minute we'll have the certificates, and yeah, we're good to go. I have everything from a developer perspective that I need to manage the container now. So we can change resources, scale the service, for example, create another instance, which will create a pod on the Kubernetes cluster. We can see that here. So there's a new deployment going on the cluster. The service itself was updated, the container was updated, and now the deployment is done. And we'll get another instance of our service in a couple of seconds here. We can work with environment variables. We can set our own port and domain settings here. So this is how the service management looks overall. But now let's not stick with just Nginx container images. Usually there's something in our GitHub, in our GitLab that we want to deploy to the cluster. So we can do that with the internal pipeline. To use that, I'm going to connect GitHub or GitLab in that case with this project. So authorizing GitHub here, selecting my account, and then we can search for repositories that we want to deploy. This only requires a Docker file in the background, so you need to have a Docker file ready in the repository, and then you're able to deploy that. So I'm going to set the branch that we want to connect with the service. We can leave the Docker file settings as they are, and then move over to resource limits. You know how it works now. Set the internal port, expose that, and voila. So now the service is not only deployed, but it's built before we have an image. So we can see that in a couple of seconds, the pipeline will start. It's showing that it's running, by the way, because we deployed a default backend here. So that the service is technically available. Now the build pipeline creates a new image, and then we are going to update the service with our new image. And in this case, it's a little Angular application just to show how to deploy an existing repository here. And this could be any repository with a Docker file in it, basically. While this is being built, it's going to take a minute probably, and then it's deployed. We can move over to the service library. So as a last step for this demo, we want to show how we can deploy templates and pre-configured services. So the service library allows you to pre-configure container images or repositories. So we can deploy boilerplate code or pre-configured images. You can see that there's a wide range of services here, front-end and back-end applications, but also CMS tools or monitoring tools, search engines, basically anything that fits in a Docker container can be configured as a template here. As an example, let's say we want to deploy an Express backend. So this is going to deploy a boilerplate repository, which means that we need to create a blank repository first, which will hold the boilerplate code. So I'm going to create a new repository in my GitHub account. Everything else is already set, and we can see that in the template, resources are predefined. Environment variables are not needed in that case, but you can also predefine them in the templates. And we have a preset port, so we don't need to worry about that. And then we can create the service. And now this will push the boilerplate codes to our new repository. And then we're going to build and deploy the service right away. So this is a fully automated workflow. Again, this is going to take a couple of seconds, and in the meantime, maybe let's check out our Angular application. It should be ready. There it is. So here's our Angular app. We also got the certificate now. And this is how we deployed the repository right from GitHub. Now let's in another last minute, let's cover one more thing. So we also have we have ephemeral containers right now running on the cluster. Everything is set up on the Kubernetes cluster. We can also invite our team basically. So I'm going to quickly invite Garrett to join me on this project here. You've role management and basic access management as well, for sure. But let's say we want to persist applications. Mogenius also supports built-in NFS storage. So you can create volumes on the cluster just by adding a volume here. I'm going to give that a basic name. And what this is doing now, it creates an NFS volume and the calling deployments to persist applications with storage that is accessible by multiple pods at the same time. So this has read-write many support, and it's extremely handy to just persist applications without worrying about storage too much, basically. Now we can use this, for example, to deploy a test database. So let's say we want to test around with a Postgres database. We can deploy one as a container. It's not managed. It's just for testing on the cluster. But we'll see that the template in this case is extremely powerful, and the storage as well. So the only thing we need to do here is fill in some environment variables. We can use the built-in key vault to do that. So we're going to generate a key. We just need to set a database name here, and then use the volume to persist our test database. So I'm just going to create a folder on the volume, set this in the owner settings, and we're done. We can create the service, and this is how the Postgres template works. We can see that the deployment is starting right away. The volumes are used to persist the container, and then we'll see that the database will start in a couple of seconds. So you can see that with just a few clicks on the user interface, and by the way, everything that we're doing here is available through the API as well, and through the CLI. We deployed our environments on the cluster, and we're basically working with Kubernetes in a self-service way without thinking too much about the whole Kubernetes complexity under the hood. So thanks for watching the demo. Hope you enjoyed it. Leave us some questions in the chat. We have a few minutes to answer these. So we can close the demo for now.
All right, Jan and Garrett. So while we wait for our audience to send in any questions, I'm going to go ahead and handle a little bit of our closing remarks. So I'd like to thank the both of you for joining us today. I really appreciate taking us not only through how the platform works as a whole, but actually showing us in your demo. I think everything was really in depth, and definitely there's a lot to take away from here. So thank you so much for all the work that goes into putting together these presentations.
Thank you.
Thanks everyone for
Thanks everyone for joining.
So I'd like to remind everyone that this session was recorded. You will be receiving a link to that recording via email as soon as it's available, but it will also be living on the DevOps website at devops.com/webinars, and be sure to look in the on-demand section. The two winners of our $25 Amazon gift card drawing are Artem T and Brian C. So congrats to the two of you. I'll be contacting you here shortly to get your gift card over to you. But if you don't happen to see an email from me, check your spam folder just in case it happens to be filtered out. I'd like to thank Mogenius for sponsoring our program today, and seeing no more audience questions. Garrett and Jan, I think you're off the hook and you're free to go today. Once again, thank you so much for joining us on Techstrong Learning. It's been such a pleasure.
Thank you very much. It was great fun.
Thank you. Enjoy the rest of your day.
All right. Thanks again for being here, everyone, and you may now disconnect.